This is the first SPSS demonstration video for Topic 3, EACS 6023, University of Oklahoma. Basically, I want to demonstrate to you how to run a correlation in SPSS. I'm using the example data file that's part of the course, the test scores database, so you might want to have that open and available, and we'll just go ahead and run correlation coefficients. Some of these variables, it makes sense to run correlation coefficients and some not. Obviously, variables like school setting, which is urban, suburban, rural, and also school type, for example, which is public and non-public, it doesn't make any sense. You technically can run a point by serial correlation coefficient, which we won't be able to get to in this class, but really if you have data like that and you want to relate those data, say, to some sort of outcome measure like post-test, it makes more sense to just compare the means of the two variables. Correlation works a lot better, I think, in my opinion, if it's with continuous variables. So we'll find some continuous data to correlate. Here specifically, I believe we have three variables that we might want to use in our Pearson correlation calculation, and that is number of students per class, pre-test and post-test. So let's start by trying to determine if there's a relationship by the number of students in the class and the post-test scores. And we might hypothesize that as the number of students increases, post-test scores tend to come down. So for a correlation coefficient, find your Analyze menu and go ahead and highlight Correlate Obvious, and we'll just do a simple bivariate correlation. Highlight the bivariate, and we tell it what variables we want to correlate. We'll correlate the number of students, put that over in the box, to post-test. And we'll just run a Pearson and keep all of the rest of it the same. And then go ahead and hit the OK button. And what we find then is a correlation between those two variables. The number of students in the classroom with post-test correlates at just over 50%. But it's a negative. Obviously, there's a negative sign, so it's an inverse relationship. As the number of students goes up, there's a tendency for post-test scores to go down. Again, as we caution you in the video presentation, not every student is going to conform to that same pattern. Excuse me, I don't know if that's entirely in your screen. But generally speaking, students in classes with smaller numbers of students also tend to score higher on the post-test score. So that's the conclusion that can be drawn from running that correlation coefficient. Of course, it doesn't imply that smaller numbers of students cause the test scores to go up. However, we have determined that there is a relationship between those two measures. Let's go ahead, just out of curiosity, and let's provide a larger correlation matrix. We'll go back up to Analyze Correlate, and we'll add three variables to the mix. We'll do, I'll just put that back in so they're in the proper order. We'll put pre-test and post-test, so we'll correlate the three variables together. Hit the OK button, and now we have a bit more of a correlation matrix. Basically, a correlation matrix is a mirror image, so you have the same things on this part of the correlation that you do on the other half of the correlation. So as you can see, the number of students in the classroom correlates at almost 50% negative and inversely to the pre-test, and just over 50% inversely to the post-test. And then, of course, pre-test and post-test correlate at not over 95%, which makes sense as the same students being tested twice, pre-test and post-test. So you would expect those scores to track each other. So there's a positive correlation between pre-test and post-test. Students that tend to score higher on the pre-test also tend to score higher on the post-test. And while we're on the topic of testing, our next topic for the class will be measurement, an introduction to measurement. So we'll resume with that topic next time.